Hello friends, and here we have another A1200. This was brought to me because there's something wrong with it. Now, these days it's difficult to get a hold of one of these for any reasonable amount of money. So my friend Brad has a few contacts, people who have spare parts, and basically this is a cobbled together A1200. It doesn't have any EMI shielding in it, which people tend to get rid of anyway, and it didn't have, he basically just bought the motherboard first, bare, and then he found somebody with a case and a keyboard, and the case has some pretty bad yellowing just on one side. It kind of, and my theory on that is that this was in a box with probably other cases, spare parts cases, sitting vertically, and because both sides of this, and even on the inside, it's yellowed. So anyway, the motherboard though is much more controversial, I guess, for Brad. He mentioned something about ordering it and it's taking a long time, and he was worried about even getting it. And then the person eventually sent it to him, and then he received it, and it only has 1 meg of chip RAM working in it. So we're just going to confirm that right now. I have everything hooked up. I have my Gotek. Of course, he doesn't have a floppy drive for this because it was cobbled together, and it's not like Amiga 1200 floppy drives are just hanging around. Although you could maybe use an A500 internal drive. I know they're not quite the same, but might be able to. It says the ribbon cable is upside down. But the nice thing that he's done is he's gotten Amiga DOS, or actually Kickstart 3.2. So let me reverse the cable, I guess. No, I did plug it in. It does have a number 1 on the motherboard. Did I completely ignore that? Yes, I did. I don't know why. That's the good thing about flash floppy on these Goteks, is that Keir Fraser has programmed it to say that when it suspects that there is a swapped ribbon cable. So 6820 AGA machine. So yeah, 1 meg of chip RAM. So that's all it's detecting. So I mean, I guess we could test the 1 meg that's there, but obviously this isn't going to help us find anything in regards to where the other 1 meg of chip RAM is. So on this Amiga, they have higher density chips than what I'm used to. 2 megabytes of chip RAM are contained on 4 ICs on the motherboard. They're soldered on. I think they're PLCC, if I'm not mistaken. So yeah, so that's passing. So there's no issue there. Let's just test the keyboard. Seems okay. Yeah, everything else seems everything else seems okay on here. So this is just a memory issue. So let's take a close look at the motherboard. And of course this arrived with, it didn't come with any screws, and Brad had to scrounge up screws, and they're all different kinds of, some of them that he had were machine screws. I mean, most people don't have a huge collection of screws. I do, but most people don't. So there we go. So the motherboard's actually not, it's loose in here. He did get 8 megabyte memory expansion from Amiga Store. And it came, he got it with the floating point unit chip on it. And battery backed up clock. So I got one of those, only mine was from Amiga Kit. So, you know, 2 different types. Okay. Yeah, you can see this, right? Look at that. It's like it was stored in a box vertically and the sun only hit it on this side. Or you know what? This looks like it sat with the motherboard on it and the sun beat down on it, because it's kind of got the shape of the motherboard in there. So something like that. And then this also has a 3D printed vented cover for the memory expansion. The one thing I noticed, and let's see, noticed right away, let's see if we can get you in there. I probably need to, yeah, let me put a lens adapter on, hold on. So here are your 4 memory chips, and I think you can pretty well see that 3 of them are the same, they're NECs, and then this bottom one is a different one. So this chip may have been replaced. So I'm going to test every one of these pins on this chip and make sure that they're not shorted and that also they have continuity where they should. Yeah, maybe I'll take some, I mean, you can usually see solder balls on high magnification. And is U9 supposed to be unpopulated? Right there? There's U26X, I think that one may be. Anyway, so I'm going to get some things together here. Yeah, so this is going to be a case where AmigaPCB.org is going to help me out quite a bit, because it gives a physical picture of the board, and then if you highlight pins on the pads, it gives you, of the PCB, it gives you the PCB. None of the chips are present, but that's good because you can hover over a contact, a pad, and with the mouse, and then it will highlight where it goes on the board, and then you can simply measure continuity between those 2 places. I'm making finger gestures and you can't see it because I was too zoomed in. But anyway, I'm going to check to make sure that this chip is actually has a good connection to the motherboard, and make some really careful examinations of it under high magnification. Just going to focus my attentions on that chip. I'm also going to, so this is U17, U18, U19, and U16. U16, 16, 17, 18, 19. That's kind of a weird configuration. But which one of these is the first megabyte of chip RAM? Because I believe the first megabyte of chip RAM is working. Otherwise, I don't believe that the computer would boot. Correct me if I'm wrong. You know what? Let's run Amiga Test Kit again, and look at the addressing of the. I didn't notice that. Let's look at the addressing of the chip memory that's on there. All right, so memory. Okay, here we go. So this is like the first 1 megabyte of chip RAM, because it starts at 0. See? Makes sense. So I'm not sure if this would say this number would be different and then it would just say 2. I think so. Yeah, it would say, because that memory would be treated all as 1. And yeah, I'm surprised this computer actually boots up at all with only 1 meg. I guess they're treated in their own address space or whatever. They're not sharing. Yeah, that's weird. I wasn't aware of that. I've never seen this problem, so I don't know. Leave a comment if you know more about memory addressing on an Amiga 1200. But yeah, I think it's odd that this is even booting at all. Who knows what happened to this board before it was sent to Brad. But it looks to me like at the very least somebody tried to fix the chip RAM and gave up or screwed it up or something. I don't know, because it obviously doesn't have it all. So anyway, that's the first megabyte of chip RAM that is only. So I'm going to find out which one of these represents the second megabyte of chip RAM, and find out which chips those represent, and then go from there. Because if the one that's been replaced is part of the first chip RAM, so if you were to think about it like U16, what it is U17 is the one that's been replaced. U17 has been replaced, and it goes U16, U17, U18, and U19. So if U16 and U17 are the first 1 megabyte, that means that this is actually working. That this chip is actually working. These two here are working, and one or both of these are not. Or logic, or broken trace, or bad Akiko. Is it Akiko that does the memory? I think so. Oh no, Akiko is is only in the CD32, right? It's Alice, I think. So anyway, it's Budgie. So Alice is here. So I'm pointing over here. Anyway, yeah, but it's kind of, it's not like this board is trash or really bad. It's just missing one of its megabytes of chip RAM. So you'd think that there would be a way to fix this without too much trouble, but you never know. So anyway, let me verify which one of these is the first megabyte of chip RAM first before we go any farther. Okay, so I did a little research, and what some people in the forums seem to know and others don't is that the 2 revisions for the Amiga 1200 have different memory configurations, a different memory map. Basically, what it is when they first came out with the Amiga 1200, they were toying with the idea of having only 1 megabyte of chip RAM. And in the end, they decided to just make it all 2. But what that caused was that, and this is a release 1 motherboard, it said it right there. It made it so that you only need to have 2 chips here, and if you're missing or broken either or both of these other chips, it will come up as 1 megabyte, because they would simply only populate the 2 here, and then this is a header right here. Apparently this header right here is for an expansion, a potential expansion card that would add another 1 megabyte. Obviously you wouldn't go to the trouble of soldering on another megabyte, but they obviously wanted it to be expandable if it was only going to be available with 1 megabyte. But all that idea was scrapped. They never came up with a board that inserted in there, and as a result, if one or both of these chips is not working, then it will only come up with 1 megabyte, and the system will actually work with only 1 megabyte, which is really strange. So I still have to determine which of these chips is the first megabyte and which is the second. I even know the address space, but I still have to find out which actual chip is which. I guess what I could do, if I can't find that information, is I can I can pull the one of the addresses to ground, I guess. I'll have to look to see if they're active high or active low, but I can basically easily disable these chips individually. I've never tried to do that before, but you know, it's safe to do. You're not doing it on the power rail. You just do the CAS, I guess, signal, and if it's an active low, pull it high or whatever. I guess I could just measure it and then put it in the opposite direction, but it's pretty safe to pull it low. So just to see that, that'll allow me to determine, because at some point on some of these chips, if I try to disable the chip, it'll make the computer boot up with a green screen. And then if I do the chip that is in the second 1 meg of address space, it will have no effect at all. So that's a way that we can at 100% verify which one of these chips. But you would assume that U16 and U17 are the first meg, U18 and U19 are the second. But you know what you do when you assume? You make a out of you and me. Okay, so anyway, I'm going to do that because I really want to know which direction to look. I want to know which chips to be testing, which traces to be testing. I don't want to have to test all of the traces for all the memory chips. I mean, it will double the amount of data lines that I have to troubleshoot. I'd rather, you know, just cut down on my time. So that's probably the best course of action there. Yeah, it's going to take a little bit more research, and then I'll get to start on testing, and then I'll let you know how all that went. Okay, so here's the information that I needed right in the schematics. There's a dotted line and it says U18, U19 optional. So this U18 and U19 are indeed the second megabyte of RAM. So there's some issue here. So that narrows it down quite a bit. And I'm going to basically, the next step is to test continuity on all these pins. Some of them are pretty easy, like these ones here are the same on both chips. They're connected together, and these ones are connected this way. So I'll just measure the appropriate pins. The signal name, or function name, is on the inside of the square here, and on the outside is the actual pin number. So that's not too difficult. And then of course Amiga PCB Explorer. Here's 18 here, and here's 18 here, and here's 19. So from the bottom, the second and fourth chip, and I can just hover over the pins and find this is pin 1 and it's VCC. So it goes around like this, and it ends with pin 40. So these are 40 pin chips. Signal video. Anyway, so I'm just going to, I'll probably test the interconnected pins first, and then like the pins to budgie and all that afterwards, and yeah. But I think, all things being equal, I'm thinking that it's probably a bad memory chip. Somebody replaced U17 and got the system sort of working, but it's got another bad 1 or 2 RAM chips here. So that's probably what I'm going to wind up doing, is having to remove them and replace them. Okay, so I actually found a pin on U18 that is an issue, although I'm not sure if this is going to fix the problem, but this pin right here, pin 21, it actually isn't making contact with the pad underneath it. It's one of the grounds that's coming off the chip. So, there are actually 3 grounds coming off the chip. But what is noteworthy is that, there's some resistance between that pin and the pad underneath it. So yeah, that could possibly make it not work. I'm going to go ahead and reflow that joint, and then we'll test it and see if that made a difference. Okay, well, cross your fingers. I don't really know if this is gonna fix it. I mean, it's an iffy thing because, you know, it's got 3 grounds on the chip, on the memory chip, and does it need all of them? Possibly not. Maybe it's, you know, I mean, that's what's connected to capacitors too. So, like a decoupling capacitor. So, yeah, who knows? Let's just make sure. Okay, let's see here. Memory. Wow. Well, what do you know about that? So, what do I think? I think that there are 2 different types of memory chips. This one is a Hyundai. I think it's Korea and it's got the H symbol. I think it's a Hyundai. And then these 3 are NECs. I think rather than thinking that this one was replaced, I think these 3 were replaced. I think that's probably what happened. I'm going to do a memory scan, and I'm just going to tap on these chips and make sure that we don't have issues. Let's just tap on. Well, guys, that was an easy fix. Boy, that was a really easy one to get to. It was right on the end. It wasn't in between 2 chips. I could physically see it. You normally can't see that. But I could actually see that there was not enough solder on there. I couldn't literally see the gap, but I guess if I shined a light correctly I would. But yeah, I'm very happy about this. Anyway, so what I did in order to test each pin and know where each pin goes, you use Amiga PCB Explorer. Oops. Which is amigapcb.org, and you can literally highlight any of the pins. So I started here, VCC, and VCC goes all over the board. That one's pretty easy to test, but I've highlighted it here, and it also highlights over here. So, you know, pin 1 of every chip, that makes sense, VCC. So just take one end of your continuity tester and, you know, probe each one of those, you know, check to see if continuity is from this pin to this pin, and then you know the pins are connected to the motherboard, and you know that the trace goes from one place to the other. Just repeat that process for each one of these. It even highlights, come on, it even highlights the, I don't know if you can see that, it even highlights the actual trace that's there. You can see that here. There's a via here, it goes all the way down here, and then it goes to this, I guess they call this a clock port header or something, but I tested the clock port, this pin right here, against this pin here, and it had continuity. So I went all the way around and up to here, and this is the one that didn't have a connection. So what you do is you highlight it, and then it doesn't, oh there it goes, you can actually see it now. Cool. So it's actually ground 1. So, and it's showing up here. So I could have tested it out here, but what I did was I clicked it. So an example of when you click it is, if you click it, it actually brings it up here in the corner. It brings it up here. This particular color is blue. The more of them you do, it changes the color, and it makes it, and each one, in other words, it's blue here and it's also blue here. So if I go here and highlight it, it tells me that on the top of the board, it's you know, 256 memory chip U19 pin 21. That's the one we're talking about. And then it says on the bottom of the board that it's connected to two capacitors, C19A and C19B. So that is, there's a via right here, and then it goes to those pins on the bottom. So all I had to do was go and look for C19A and B right below the memory chips. And here they are, C19A and C19B. So I just tested one of my probes on here and the other probe on the top of the board while holding this vertically, and I was not getting a continuity. I was getting some resistance. It was going, in other words, it was going through some logic or the chip or whatever. It wasn't giving me a dead short, and it should. So that's when I looked and found the, under close examination, I could see that pin 21 seemed to not have a lot of solder on it, and sure enough, when I added solder, solution. So to look at it in the schematic, if you're interested, I have it up here already, but basically here's the A1200 schematic. Here are your memory chips. Here's U19, the one we were actually looking at, U19, and you can see if you look on here, you don't see pin 21. And so this is the way a lot of schematics are. If there are capacitors on the power rails next to the chips, they will separate them. Actually, in most cases, because there's so many pins and because you were trying to trace all the logic and data here, basically it's tradition to separate the power rails down here. So as you can see, here's U19 right here, and you can see that all the grounds are hooked together, and pin 21 was just, there was no connection right here where that little circle is. There was no connection there. So yeah, I've already explained all that, but anyway, so that's if you don't have the ability to, if you don't have a resource like this, which is excellent to use. This made my job, it cut my job in half at least, if not more, because I could actually see literally where it goes on the PCB. I could see the PCB, what I have in front of my eyes, where it goes without having to use a microscope or heavy magnification. Or, I mean, with the chips mounted, you can't see where these traces go. So having this without the chips mounted, even just this, would be great. But this thing where you can highlight them and it'll show you where they go, that's just game changing. So we're just going to test a game real quick to end this video. Okay. Just make sure it works with the game, right? James Pond, underwater agent. Looks like it's going to work. Okay, well, it looks like it's working. Thanks for joining me, friends, and we'll see you on the next one.